This is Golang for Devs, a series where I blitz through all things Go so you can get back to your life and building cool stuff. Today I'm covering generics, and this should be a pretty quick one, so let's get to it. Before we dive into any code, I wanted to briefly go over generic type constraints. When you define a generic type in Go, you need to specify a constraint that limits what types that generic type can be. So for example, if I want a generic type that can only be a string or an int, then I can make a custom constraint that limits that generic type to only those two base types. But there are also a number of predefined constraints you can use. First, Go has two built-in constraints. The first is any, which means the generic can be of any type. And the second is comparable, which means the generic type can only be of a type that supports equals equals and not equal. So think things like ints and strings and floats. Then there's an ordered constraint in the standard library that restricts a generic type to only be types that support less than and greater than operations. And lastly, there's a bunch of self-explanatory constraints that are provided by the x/exp/constraints package. And that's not part of the standard library, but it's still maintained by the Go team. Okay, let's get to some actual code. We'll start with using generics in functions. I covered this in depth in my last video, so if you want to skip ahead, feel free. And if you want to see the previous video, the link is in the description. So here's an example of a function using a generic type t. T is the name of the generic type that you'll use to reference it in the rest of the function definition, and cmp.ordered is the type constraint. So once you define it in the square brackets after the function name, you can then use it in the input parameters section and in the result parameters section. Okay, you can call a generic function in two ways. The first is just calling the function normally, and Go will use type inference to determine what the actual type of t should be. The second way is by explicitly setting the type with similar square bracket notation. And here's an example of a more advanced function definition with multiple generic types. So let's step through this slowly. First, after the function name, you define your generic types in square brackets. There are two generic types, t and r, and the type constraint, any, is applied to both of them. So both t and r can be of any type. The function accepts an input slice of type t and a function that takes in a single type t and returns a single type r. And then it returns a slice of the type r. So the goal here is to take a slice of any type and transform it into a slice of any other type using a map function that we provide. So first we make a new slice to store the results in, the same length as our input slice. Then we do a range loop over the input. And for each value in the input slice, we are going to call the function that was passed in to transform it into the other type, and then return the results. So this is a good example of how generics can be super useful, because we can use this function to map a slice of any type you want into a slice of any other type you want. So it's super flexible. Go also lets you apply generics to custom type definitions. So here we have a mystery box struct type. Now this mystery box can hold any type, so we need a generic type t with the constraint of any. And then you can use this generic type when you define the fields of the struct. So this struct has one field called value of type t. Then when you create an instance of a mystery box, you need to specify the generic type that you want t to be, and then you can set the value. And just like with functions, you can use multiple generic types with a struct. So I can have t1 be of any type and t2 be comparable. So then you can have fields of both of those types. The generic types used in the type definition can be used in methods that you attach to the type as well. So I can add a method to the mystery box, but I have to put T in the brackets here if I want to use it. And this returns the T type. One gotcha to note in Go is that methods don't let you use generics in the function definition outside of the generics defined by the type. So if I wanted a second generic here, accept it as an input argument, then I couldn't do that. And you can apply generics to any custom type, not just structs. So for example, if I wanted a custom list type that could have any type in it, then I can do it with generics like this. Same thing goes for custom map types, but you need a key type, which needs to be comparable for a map, and a value type, which can be anything. And then you can do interfaces the same way you do structs, where you can use the generic type in the function definitions. Okay, the last thing I want to cover is custom constraints. And you do it using a special type of interface that includes a type set. So if I want to limit a type to a string or an int, I can have an interface that lists those types in the type set. The tilde here means that any type that has an int as its underlying type is acceptable. So if I had a custom int type, then that would work. And if you take out the tilde, only an exact int type could be used. Now that we have a type limited interface, you can use it as a type constraint in any of the generic examples I showed earlier. So for example, if I have another struct type, I can use the string int interface as the type constraint. And then the value must be of an int or a string type. You can also still add methods to the interface. And this basically means that any string int generic only accepts types that are based on ints or strings and also implement the print method. And one last super important point here, this is not a regular interface. So even though you use the interface keyword, this is only used as a type constraint. You can't have a variable of type string int. And that is all you need to know about generics. Thanks for watching, and if you learned something, give the video a thumbs up and subscribe. As always, keep breathing, keep building, and I'll see you next time. Peace out.